So today I'm going to be walking you through my ThinkerCAD designs for the AND gate, the NAND gate, and the OR gate. So first I'm going to be talking about the AND gate. So how the AND gate works is that it only turns on the output when both inputs are true. For example, if I press the button here, it doesn't turn on. If I press the button here, it doesn't turn on because these are only one of the inputs. But if I press shift and I press both buttons at the same time, the output lights on, because in order for an AND gate to work, if both inputs are true, then the output is true. But if only one of the inputs is true, then the output cannot be true. Additionally, for AND gates, if neither inputs are on, then the output is not on either. Next, I'm going to be talking about the NAND gate, or the inverse of the AND gate. So the NAND gate, or the NAND gate, essentially works in the inverse way that the AND gate works. For example, if neither inputs are on, but for the NAND gate, if neither inputs are on, the output is actually on. If one of the buttons are pressed, the output is on. If the other button is pressed, the output is on. However, in the way that's the inverse of the AND gate, if you press both buttons at the same time, the output actually turns off, as you can see here. So it's essentially the inverse of the AND gate in the way that the output is on, true. If neither input is on, one input is on, but when two inputs are on, the output is false. Finally, I'm going to be talking about the last gate, which is the OR gate. The OR gate essentially works in the way that the output is on when one of the inputs is on. So if I press this button here, the output lights on. If I press this button here, the output lights on. However, if I press both inputs, if I press both inputs, the output actually lights on as well. However, if neither inputs are pressed, the output does not light on. So how the OR gate works is essentially if one input is true, then the output is true.